All right, real quick, waves refresher. If we look at this wave, we want to talk about the period. That's the amount of time per wave. So how long does one wave take to go by? If we flip that idea around, we want to talk about the frequency. That's how often the waves are going by. So how many waves per time? For period, it's amount of time. So we usually give it a capital T. Frequency is an F, as you'd imagine it would be. This is measured in hertz or cycles per second, waves per second. The period is in seconds because it's the amount of time for one wave. And if you can kind of already see, these two things are inverses of each other. So as soon as you know one, you know the other one. If we want to relate that to wavelength and velocity, if you think about wavelength is the distance between basically the distance of one wave measured peak to peak, trough to trough, midpoint to midpoint. As long as you're measuring to the same place, that distance should be the same. But that's your wavelength. If you know how far a wave is and how often it goes by, wavelength times frequency will give you the velocity. So V equals wavelength. We typically use a Greek letter lambda for length, which looks like a little A, or I think it kind of looks like a wave that's cresting, but wavelength times frequency. Now, frequency is the inverse of the period, so you could also think of wavelength as distance over time, specifically the distance of one wavelength, over the time for one wave, the period. So distance over time. Either way you do this, it'll work. And that's the relationship there. So you have frequencies, the inverse of the period. You have the velocities equal to wavelength divided by period, or wavelength times frequency. Either way you want to do